Now, in our last class, we have discussed up to this deterministic and random signals. So today we will be discussing about the even and the odd signals. So they are pretty easy to understand. When a signal, if say it is x of minus t is equal to x of t in the continuous time domain, and in the discrete time domain if it is x of minus n equals to x of n, then they are called even signal. Otherwise, if uh, it is x of minus t is equal to minus of xt, or x of minus n equals to minus of xn, if this condition is met, then the signals are regarded as odd signals. Now let us see in the graphical way. So what does this mean? So if you see in the first case, if we have a sinusoidal signal like this, if you see over here, if we consider this part, okay, and if we consider this part, so say if we say it at is equal to minus of a minus t, or a of, yeah, minus of minus t equals to plus a of at. Okay, so if you go back, it becomes, yeah, it becomes, if you see over here, it is the odd signal, right? So minus of this thing. So in the positive half, whatever you are having, the same it is being repeated in the negative half, but in the opposite way. The positive half, it is present in the negative domain, and vice versa. If you consider the second this half cycle, it is over here as the negative one, here it is as the positive one. Okay, now if you want to see it in a mathematical way, so what is happening over here? If you see x of minus of n, it is equal to sine of minus 2 pi n. So we can take this negative out, so it becomes minus of sine of 2 pi n because of the trigonometric functions. So it is nothing but minus of x of n. Therefore x of n is equal to minus of x of minus n. So this is an odd function. Okay, on the contrary, if we consider the cos 2 pi n, graphically if you look, this positive half, it is being replicated in the positive half of the minus n. Okay, and again this negative half, it is being replicated over here. So x of minus of n is equal to sorry, x of minus of n is equal to uh, x of n. Okay, so this is an even signal. Okay, now again if you look over here, x of minus of n is equal to cos of minus 2 pi n. However, in this case, cos of minus 2 pi n is equal to cos of 2 pi n, and we get xn. So x of minus n is equal to xn. So this condition is met. So this signal xn equals to cos 2 pi n. It is an even signal. Okay. Now any signal, it can be represented into a combination of even signal and odd signal. Okay, so yeah, so if you see over here, when we say that it is an even signal, so even signal is equal to half of x of n plus um, x of minus of n, and odd signal, it is given by half of x of n minus of x of minus n. Okay, so this is the even signal. even part of the signal, and this is the odd part of the signal we have just discussed. Now any signal, it is given by even component plus odd component. Okay, even component plus odd component. This is important to note. Okay, another important thing is that when we multiply two even signals or two odd signals, then the resultant signal what we get is the even signal. And if we multiply two even signals, sorry, an even signal and an odd signal, then the signal would be an odd signal. Okay. Now coming back over here, if you see xn, it is given xn equals to k of e to the power minus n multiplied by un. Okay, what is un? Un, it is a step function. Now when it is a step function, it makes the signal right-handed signal. That means it the signal would be present only in the positive time domain. Okay, so and it is basically right-handed signal. Okay, so k e to the power minus n un. Okay, so if we calculate the even function and the odd function, if you see the even function, we know it is given by half of x of n plus x of minus n. Okay, so x of n 1 by 2, this half k multiplied by x e to the power minus n multiplied by un. What is this? This is nothing but your xn component, if we call it as a. Okay, plus k multiplied by e to the power n multiplied by u to the power minus n. This becomes the b x of minus n, because what we do over here, whatever, wherever we will be having the n, we will be replacing it with minus n. So your minus n, it would become plus n, and this was n over here, so it will become minus n. So this is the b component of this signal. Okay, now if you see the k component, it is this one. So your amplitude would be k by 2, and then it is a decaying function in the positive half, right? Similarly, k by 2 would be the maximum amplitude, and it is an exponentially growing signal in the negative time domain, so it is increasing. So we are having a and b. Okay, so if you add up these two values, so what we have to do, xen, it is nothing but a plus b. If we consider, as we have considered this half into both these coefficients, k by 2 we have already done it. Okay, so what would be the even function? Even function would be this a plus b, right? So if you add up, we get this as the even function. कहाँ खोए हुए हो? क्या सोच रहे हो? स्लाइड्स इधर है, नीचे क्या देख रहे हो? समथिंग यू आर थिंकिंग, क्या सोच रहे हो बता दो. नहीं, okay. So next is similarly, we are having this a component and b component, and x odd of n. Since we have taken this half, so we just have to subtract this b from a, right? So this is graphically, you can see these signals are present over here. So this would be in the present positive half, it would be okay. At 0, k minus 2, minus of k minus 2, it would be 0. If you see, the value is 0 over here, and the b component, since there is a negative this thing, it would be in the inverse uh, way. Okay, so this is the even component of the signal, and this is the odd component of the signal. Okay, any doubt? It is as simple as that. When you are having any signal xn, it is given by um, xe n plus, okay, from here we get this thing. Any signal xn, it is given by xen plus xon. Okay. Now, any signal can be broken down into the even and the odd component. How you can break it down? Xen is given by half of x of n plus x of minus n, and odd component it is given by half of xn minus of x of minus n. Okay. Now, in the same way, you can get over here. We are given with xn, which is equal to 0 for n less than 0, and 2 for n greater than equal to 0. So, this is your xn. These amplitude values, all of this, it is basically a step function. If you see, okay, for n greater than equal to 0, we are having a value of 2. Okay. Now, xen क्या होगा? Half of xn plus of x of minus n. Okay. x of minus n क्या है? Right. At negative intervals, nothing. Positive, we are having 2. X of minus n, this is called time inversion. Okay. So we have to flip the signal around. So yesterday we have talked. So we have to match this thing. If you have to add it, this is 4, then 2, 2, 2, 2. Okay. So we are basically getting 2, 2, 4, 2, and it will repeat. And then we are having half, multiplier of half. So at origin, after multiplying with half, it becomes 2, and the rest of them it becomes 1. So if you see xen, it is given by this thing. At origin, it is 2, and in the rest of the things, it is like this. Now, if it is minus of a to get the odd component, so 2 minus 2, it would become 0, and all these ones it would be in the negative half, because we are having a multiplier of minus 1, because it odd component is given by xn minus of x of minus n, फिर उसके आगे half, right? So because of this negative sign, the signals over here, it is what do you call it? It is in the negative domain. Okay. Any doubt? क्या डाउट है? नहीं है? नहीं है? Okay, good. So again, over here we have some things over here. So examples of even signals A and B. So these are even signal. Okay, 0 0 में ठीक है. Say if it is t equals to 1, t equals to minus 1, same value. Say t equals to 2, t equals to minus 2, same value. So these are even values. Similarly, this is also even value. Here, it is an odd signal. It is an odd signal. Okay, this I have already told you. if two even signals or two odd signals they are being multiplied, then we get the even signal. Otherwise, if we multiply an even signal and an odd signal, then it would be an odd signal. Now, over here, let's find out some even and the odd components of, in this case. Say, for example, we are given with xn. Okay, so 153. So there should be a pivot over here, pivot 252. Okay, we may give you this kind of some signal component. Then x of minus n, I told you how to find out. We will be just flipping it. So from this way around, we will start writing 252, 252, then 4, 351. So we have written this. Now for getting the even component, xn plus x of minus n. If you do, you get this thing: 2 plus 1 3, 5 plus 5 10, 3 plus 2 5, then 4 plus 4 8, and so on. So you get this one, and to get the even component of the signal, you just multiply it with half. Similarly, for getting the odd component, xn minus of x of minus n, you get this multiplied by half. Okay. Yeah. Now, we already told that there would be on the this xn, they are made up of xen and x0n, and which is given by xen plus x0n, right? Now if you see, if we add up xen plus x0n, xon, not 0, xon, so half plus of minus zero point 0.5, it is 1. Say we name it as x dash n, we don't know whether we will be getting the xn or not. Similarly, we have 5 plus 0, 5, 2.5 plus 0.53, 4 plus 0, 4, 2.5 minus zero point 0.5 is 2, 5 plus 0, 5, and 1.5 plus zero point 0.5, so 2. So if we compare it with xn, both x dash n and xn, they are equal. Okay. So periodic and aperiodic signal, we all know what are periodic signals and what are not aperiodic signals. So periodic signals, they are being written as xt equals to x of t plus t0. Okay, where t0 is the uh, time period or the periodicity of the signal. If it is a periodic signal, so if you have a signal like this, so this one wave, after which the signal components repeat itself, it is the time period. And after every t period, if you see, if we push this origin over here, we will be getting the, if we say an origin dash o dash, then we see the signal again starts itself to repeat over here. So with this time period, the signal becomes periodic in nature. Okay, so if any signal, it is um, following this equation, x t equals to x of t plus capital T0, then it is called a periodic signal. And if it is not following, then it is called a periodic signal. Okay. So this is a periodic signal, continuous time periodic signal. This is an a periodic. This is also a discrete time periodic signal. Now, I will be mainly discussing about this discrete time, this thing, discrete time periodicity, and not the continuous time, because digital signals, they are basically the discrete time signals, and I do not have time to cover up the continuous time periodicity also. So in your syllabus, we will be basically discussing about the periodicity in terms of the discrete time signals. So when we talk about the periodicity of a discrete time signal, uh, any periodic signal, it should follow this consideration capital N. What is capital N? So if you remember, I told you that in discrete time, this capital small t, it is being replaced with n. Xn equals to x of n plus n. Okay. Now this n, it is nothing but your period is this time period. So n equals to 2 pi by omega naught n, and the rule is that this capital N, it should be a rational number. It should be a rational number. So let us take an example. Xn equals to e to the power j pi n. Okay. What is the omega naught over here? Omega naught over here is pi. Okay. So n is given by 2 pi m divided by omega naught. Omega naught is pi. So this pi cancels out from the numerator and the denominator, and we get 2m. And if we consider m as 1, then we get n equals to 2. So this signal x of n is equal to e to the power j pi n. It is periodic in nature. Our next question is cos of theta plus phi. Phi. So xn equals to cos of n by 8 minus pi. Okay. Now let us consider that this can be written as n by 8 multiplied by 1 minus pi. Okay. So this omega naught over here, because we are having this theta component, this theta component, it is basically, it would contain the frequency component, whereas this phi component, it is basically regarded as the phase component. So herein, when we compare these two equations, we have cos of n by 8. That means if we multiply it by 1, so we get n multiplied by 1 by 8. So n is the time. So what is the frequency component over here? The frequency component is omega 0 equals to 1 by 8. Okay, minus of pi. Pi is the phase. Now if you see n equals to 2 pi m, it comes from here, divided by what is omega naught? Omega naught is 1 by 8. So we get 16 pi n. Over here, if you see, due to the presence of this pi, this n is not a n is not a rational number. And if it is not a rational number, then that means it is not a periodic signal. It is an aperiodic signal. Similarly, let us take another example. Xn equals to sine square pi by 4n. So xn equals to half minus half cos 2 pi by 4 n. I hope how it came everyone knows. Okay, so I'm not going telling the equation over here. So if you see this xn, it is composed of two components, x1n and x2n. In such a case, what we have to do, we have to find out the n for each of this. So if you see, x1n equals to half of 1 to the power n, and n1 is given by 1. This is a constant, and n1 is given by 1 because it is just 1 which is getting repeated. Okay. On the other hand, so it is a rational number. On the other hand, x2n is given by minus half cos of 2 pi by 4 n. So it gets cancels out pi by 2 n. So minus of half cos of pi by 2 n. So this pi by 2, it is your what you call omega naught. So n2 equals to 2 pi divided by pi by 2, then capital N, it comes out to be 4n. If we consider n is equal to 1, then we get n2 equals to 4. Now the thing comes, n1 by n2, it is equal to 1 by 4. Okay. Now we can write it down as 4 of n1 equals to n2, and this is equal to n. Now to calculate the n, what we have to do, we have to find out the LCM of these what we call constants which are being multiplied with n1 and n2, and if you find out the LCM, it comes out to be 4. N equals to 4, which is basically a rational number, and since it is a rational number, this signal x of n sine square pi by 4 n, it is a periodic signal. Okay. Now similarly, um, you will be able to do the thing for xn equal to sine of 2 pi by 3 n plus cos of pi by 2 n, and if you solve in this manner, you get n equals to 12, which is a rational number, and this is a periodic signal. Now coming to the next category of the signals, energy and the power signals. What it is called, uh, a signal with finite energy, it is an energy signal. Okay, a signal with finite and non-zero power is a power signal. Finite energy, energy is, then the signal is called energy signal. If we have finite and non-zero power, then it is a power signal. And the in the continuous time domain, the energy of a signal is given by equals to integration of minus infinity to infinity modulus of xt whole square dt. Okay, whereas this normalized average power, so it was, previous one was the normalized energy content, and the next one is normalized average power. It is given by p equals to limit t tending to infinity 1 by t integration of minus t by 2 to t by 2 xt modulus of xt whole square dt. So this would be the power of the system. Similarly, for the discrete time signals, this integration, they are being replaced with the summation. Okay, and this power limit of capital N tending to infinity 1 by 2n plus 1, then summation of n equals to minus n to n x of n whole square modulus of x of n whole square. Okay, now if you see in power, as compared to this energy, there is one extra factor 1 by t over here, and 1 by 2n plus 1. Okay, why this is so? This is so, I will tell you, because usually it has been seen that the periodic signals, they are power signals. Okay, energy signals, they are time limited signals. Okay, what do you mean by time limited signals? Suppose you are having a signal, you are having in the time axis varying from, say, minus infinity to infinity, whether it is t or n, I am not discussing. On an overall, I am discussing that if it is a time axis, so where the time is varying from minus infinity to infinity, so what would happen? Your signal component, suppose like this, you are having some signal component, it is time limited. That means after a specific time, both in the negative domain and in the positive domain, the amplitude values would be 0. Whereas in the power signal, one of the classical example of the power signals are the sinusoidal signals. Say for example, sine wave or cosine wave. So let me draw a sine wave. So what would happen? Will you be able to find out the energy? Because limit will be applied from minus infinity to infinity. So it will become very difficult for you. So in that case, if you see what they are doing, they are selecting a range minus t by 2 to t by 2. Okay, suppose this is the minus t by 2, t by 2. Usually what should be the t should be from the origin to here, right, and also from here to here. So we are taking minus t by 2 to plus t by 2. That means we are basically taking one time period. You could have taken it 0 to t also, doesn't matter. So we are taking one time period. Okay, and then we are saying that this fraction what we have cut, we are considering that this t it is tending to infinity. Okay, so using this logic, we take a particular section and from there we try to find out the stuff. So in this case, if we get a power which is a non-zero power, then it is called a usually a power signal. Now, it is not the only criteria. There is another thing. If you see energy signal, total normalized energy is finite and non-zero. So that means what it says, energy for an energy signal, energy should be finite and non-zero. Okay, and power of this signal, energy signal should be zero. Power of the signal, it should be zero. It is for the energy signal. You're getting my point. On the other hand, power signals, so energy is infinite. It is quite understandable from here because our limit, it would be tending to infinity, and our sinusoids, they are spanning up to infinity. Okay, so if you want to just find out the integration of that whole area which is spanning up to the infinity, it is not possible. So it would be the infinity. So energy signals, they are having a value, power signals, they are having an energy of infinity, whereas the power of this signal should be finite and non-zero. So please keep this in mind, these two factors in mind. This is the important stuff. And again, I told you that these signals are time limited signals, energy signals, and power signals. These signals can exist over infinite time. And I also told you the power signals, they are usually periodic signals, and over here energy signals, they will be obviously the aperiodic signals. Okay, now here I have just written what I have told you just now. Energy signal is finite, energy is finite, and power is zero. And for power signal, power is finite and energy is infinite. Okay, so let us take some examples. Xn is equal to a delta n. Delta n, we have discussed that it is equals to 1 for n equals to 0. Okay, so herein, if we solve it, we get, since it is a, that means a for n equals to 0, and for other, all other n values, we are having an amplitude value of 0. So energy, it is given by summation of n equals to 0 to 0 a square, which is equal to a square. Then we call, if you see, energy is finite. Okay, only and only if you have to write, only and only if a is finite. What happens if a is infinite? Okay, so if a is infinite, then then this is not finite. So you have to write, under this condition, if some value is given, it would be a definite value. So you have to write that if a is finite, then this xn equals to a multiplied by delta n, it is an energy signal. Okay. Then let us take the next one. Xn equals to u of n for n greater than equal to 0. It is a step signal. So energy is equal to infinite, because un, it is an unlimited series and it spans up to infinity. It starts from 0 and it spans up to infinity. So obviously energy would be infinite. So we have to put, calculate the power, limit n tending to infinity, 1 by 2n plus 1, summation of n equals to 0 to 1. Okay, so if you look into the series, summation of n equals to 0 to capital N 1 equals to n plus 1. So this is the solution for this part. Okay, now let us put it in this equation. So limit n tending to infinity, capital N plus 1, divided by 2n plus 1. Okay, so if you take n common from here, so this n cancels out, and putting infinity, 1 by infinity is 0, 1 by infinity is 0, so we get power equals to half. So power equals to half, energy equals to infinity, so it is a power signal. Okay, then we have another interesting xn equals to ramp n. Okay, ramp means with time the signal continues to increase. Okay, and it is said that for n greater than equal to 0. So xn equals to n for n greater than equal to 0, and 0 for n less than equal to 0. So if you see, with time, as the time increases, this signal is continuously increasing with time. Okay, so E equals to limit n tending to infinity, summation of n equals to 0 to n square. So for this series, if you see, I have written the series expansion. So n multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. So if you try to solve this, we get uh, uh, this. You put this infinity over here, we get infinity. Energy is infinity. Similarly, if you solve this, we get P also, it is equal to infinity. So what does this mean? This means both energy and the power signals, they are infinity. Neither of these criteria are met. So this signal is neither an energy signal nor a power signal. Okay. Now again, coming to the another yeah. So if you see, if we go for this signal xn equals to cos pi by 2n, we get power equals to half. I'm not going into the details. Power equals to half, and E, it is equal to infinity. Okay, so this is a power signal. It was quite obvious because it is a cos signal, which is a periodic signal. Okay. Now, coming to causal, non-causal, and anti-causal signals. So before going into this mathematics, let's see what are causal, non-causal, and anti-causal. Causal means any signal arising at t or n equal to 0, and it is moving on the right hand side. Okay, so this is called causal. Okay, so we always consider that n is our present value, and on the right hand side, whatever the time will be coming, they are our future. Okay, so they are our future. Okay, that means the signals which are coming on the right hand side, they are futuristic signal component. So what do you mean by cause? Cause means there must be some event to have an effect in the future. Okay, so in the future we should have some event. Okay, in the future due to an event we should have some cause. So in this case, what happens over here, uh, if you see, all the amplitude values, they are in the futuristic system. That means due to some event, these amplitude values, they are happening. Okay, now what about the non-causal? The non-causal signals, they start before the event starts. Before the event starts. Okay. Okay. So they would be starting somewhere in the negative n or t values, and they may or may not continue in the right-handed inside. Okay. So causal systems, they are right-handed signals, purely right-handed signals. Non-causals, they are originating at the left hand side of the plot or the negative time domain, and they are extending up to the futuristic values, positive t values, or they may not even extend up to the futuristic values. Okay. And lastly, we have the anti-causal, which is anti of the causal. That means this causal, we have said that they are right-handed signals. Anti-causal signals, they are totally left-handed signals. Okay. They only exist in the time region of minus infinity to 0, okay, or less than 0 in fact. So a signal that does not start before t equals to 0 is a causal signal. In other words, xt is causal if xt is equal to 0 for t less than 0. A signal that starts before t equals to 0 is a non-causal signal. A signal that is 0 for all t greater than equal to 0 is called an anticausal signal. 0 that is 0 for all t greater than equal to 0 is called an anticausal signal. So some useful signal operations: time shifting, time scaling, time inversion, and combined operations. Time shifting, what is the time? Yeah, finish. So if you see ft, if we time shift by an unit of a, then it becomes f of t minus a. Okay. So f of t minus a. So suppose we are shifting the signal by a value of a. Okay. So there is a signal component over here. If we move it on the right hand side, then it is called delaying. Then we call it delaying. Okay. So when we are shifting it on the right hand side, then it is called delaying. If you see the origin, now if you consider this thing, we have shifted this origin to the left hand side. Okay. If you consider this as the after we have done the modulation, if you consider this one, so from here, from this center, we will shift the origin to the left hand side. Okay. We are basically shifting the reference point. Similarly, x of ft, which is being transformed into f of t plus a, it is nothing but ft f of t minus of minus a. Okay. So we are shifting the signal towards the left hand side. Okay. So we are shifting the signal to the left hand side, but what is happening to the origin? If you see during the numerical, we will shift the origin to the right hand side. Okay. So the first one, it is called delaying because I told you when we are having the positive t, so in the right hand side we are having ये we are having इसको क्या कहते हैं, we are going into the future, right? So when we have to do something now, and if we say that I will be doing it after say 1 hour, what we are doing, we are basically delaying our work. The same thing happens over here. So since the signal is moving to the futuristic values, so we call that over here delayed. It is called the delaying of the signal. Similarly, in the second case, we call it advancing of the signal. Suppose at 10 a.m. I had to do something. I have advanced my time schedule and I started it at 8. We call it advancing. So the second part, it is called advancing. So the same thing, if you see Fn equals to 1 3 this thing, suppose this is the pivot. Okay, if I have to delay the signal, I have to move this pivot to the left hand side. So we have moved this pivot to the left hand side. Now this is the origin. If you see, the signal is starting from here. Okay, so advancing by 2 unit, we have put it over here. Now you see, now this signal, it is starting before the origin. So this is called advancing. Similarly, from here you can draw these curves, right? So suppose if you are given with Fn where you are having this thing at 1, origin at the 1, then we have to shift this what you call pivot to the left hand side by 2 units. Okay. Now coming to the time scaling, here we have ft equals to ft, it is being transformed into f of at, and ft, it is being transformed to f of t by a. Okay, so it is just like 2t, or we can also say 2x. So if you play a tape recorder, say at 2 times of the speed, then what it is called, that we are fast forwarding it. And suppose you are watching the movie by for 2 hours, it will be completed within 1 hour. And the same thing happens over here. If you see, this was the original signal, and this is the signal after the transformation. So it has shrink. So it is called shrink signal by a units. Okay. Whereas if you divide it, so t by a, that means you are playing at a speed of 0.5x. So t by a, what it is? T by 2, it is nothing but a 0.5x. Now when you do that same 2 hour movie, you will be able to see it in a 4 hour time span. Again, if you see over here, so it is called the stretching of the signal. So time inversion, we have already discussed that across the origin we will be flipping the values. Now if you see over here, when we have Fn, say this is the Fn, and now I am being asked you calculate f of 2n. So this is the origin. So 2n, how will you put? We have to slice some objects. So 2 means after every from where you are starting, every second values will be cut. So you are here 3, the second value is here, this will be cut, 1 will come down, then again the second value it will be cut, then 5 will be coming down. Similarly over here 5 will be cut, 4 will be coming down, then 3 will be cut. So in this way you get f of 2n. Okay, now here if you see the new time value scale, which is the 2n scale, it is -1012. Okay, i'm I am telling 2n scale, but in reality it would be the n value. So -1012. Okay, we don't write it. And yeah, another important thing, here we forgot to mention the pivot. The pivot should be here. Okay, at 3, because origin does not change. When you start the movie, whether you are placing it playing it at a 2x speed or a 0.5 speed, it starts at the same point. It would always start at the 0. Okay,